Hi students, welcome to chemistry classes. Students, in last class we explained about the nitric acid, means preparation of nitric acid and properties of nitric acid and structure of nitric acid and the uses of nitric acid. And in today's session we are going to start with the next group 15 family member, that is phosphorus. Means here we are going to discuss about the phosphorus and allotropic forms of phosphorus and phosphine and their properties and their preparation and their uses. So let us start with the first one, phosphorus. So student, first one, phosphorus, it was first isolated from bone ash. Phosphorus, okay, it was isolated from bone ash by sheep. Bone ash by sheep. Okay students, phosphorus, it was isolated from a bone ash. And students, phosphorus, it has a main three principal allotropic forms of phosphorus. They are white phosphorus, red phosphorus and black phosphorus. So these three are very important. So let us first one, I will write here. Phosphorus has three principal allotropic forms. Phosphorus has three principal allotropic forms. They are, first one, that is white phosphorus, and second one, red phosphorus, and third one, that is black phosphorus. White, red and black phosphorus. So these three are the main three allotropic forms of phosphorus, and that in that first one, white phosphorus. Okay, so it is important for our theory annual examination. White phosphorus here I am going to write the properties of a white phosphorus. They are the white phosphorus properties are, first one, it is soft and waxy solid. Means it is solid in nature. First point, it is soft and waxy solid. Second one, it is not soluble in, or you can say insoluble in water. It is insoluble in water. So here student, white phosphorus is insoluble in water and soluble in carbon disulfide and soluble in carbon disulfide, CS2 ಅಂತ ಕರೀತೀವಿ. CS2. It is insoluble in water and soluble in carbon disulfide. And next one, it is poisonous in nature. It is poisonous in nature and has garlic odor. It is poisonous in nature and garlic odor. Means it smells become garlic. And next one, it glows in dark. It glows in dark due to slow oxidation, and this process of glowness in dark is called a chemiluminescence or a phosphorescence. Okay, the first point, it glows in dark due to slow oxidation. It glows in the dark due to slow oxidation, and this phenomenon is called, this phenomenon is called chemiluminescence. Chemiluminescence, or you can say phosphorescence. And next one, it dissolves in concentrated NaOH. It dissolves in concentrated NaOH in inert atmosphere of carbon dioxide. It dissolves in concentrated NaOH. I will write a reaction here. That is phosphorus P4 when react with the concentrated NaOH in the presence of water molecule, it forms phosphine. It forms phosphine, that is pH3, and the byproduct is 3NaH2PO2. 3NaH2PO2. It is called a sodium hypophosphite. It dissolves in concentrated NaOH, P4 plus 3NaOH plus 3H2O. It gives rise to pH3, means phosphine, and the byproduct is 3NaH2PO2, that is called a sodium hypophosphite. And student, it is a more reactive and a less stable compound. This white phosphorus is less stable and more reactive. Less stable and more reactive because it has a structure like this. The structure of white phosphorus is like this. Means here the tetrahedral angle here, angular strain is only 60 degree. This is P4 molecule. Okay, this is the 60 degree only bond angle. So due to angular strain in a P4 molecule, it is a more reactive and less stable, and it is trigonal in shape. Okay, so it is less stable and more reactive. So more reactiveness is due to the angular strain is very less, that is only 60 degree. Okay, so this is about the white phosphorus. Take it. Next one, student, here. Second allotrophic form of phosphorus, that is red phosphorus. Red phosphorus. This is second allotrophic form of phosphorus. The properties of red phosphorus, they are: first one, it is colorless solid. It is colorless and having iron gray luster. It is colorless solid and having iron gray luster. It is insoluble in water as well as carbon disulfide. It is insoluble in water as well as carbon disulfide. Okay. Next one, it is non-poisonous in nature. It is non-poisonous in nature. And next one, it does not glow in the dark. Means chemiluminescence or phosphorus property is absent in the red phosphorus. It does not glow in the dark. Due to absence of chemiluminescence or a phosphorus property. And next one, the structure, or I will say it is made up of, means the structure of red phosphorus, it is made up of tetrahedral P4 molecules. P4 means phosphorus molecules. It is made up of tetrahedral P4 molecules connected to each other. Means P4 molecules, they polymerizes to form a red phosphorus. Okay, I will explain it with the help of a diagram. Okay, before going to that, preparation of a red phosphorus. Preparation of red phosphorus. So here, student, red phosphorus is obtained by the heating of white phosphorus at 573 Kelvin temperature in an inert atmosphere. It gives a red phosphorus. red phosphorus, it is obtained by white phosphorus, sorry, it is obtained by heating white phosphorus, by heating white phosphorus at 573 Kelvin temperature in an inert atmosphere. In an inert atmosphere. Here student, white phosphorus is heating at 573 Kelvin temperature in an inert atmosphere. It gives a red phosphorus. It gives red phosphorus. It gives red phosphorus. And here P4 molecules, they joint, they polymerizes to give red phosphorus. This is the P4 molecule, sorry, red phosphorus structure. Phosphorus, phosphorus, phosphorus. This is a one P4 molecule. They join together to form a red phosphorus. Means here P4 molecules polymerizes to form a red phosphorus. And student, it is less stable and less reactive and more stable. This is more stable and less reactive molecule. More stable and less reactive molecule. And it catches fire and it reacts with the strong oxidizing agents. So this is about red phosphorus and their properties. And next one, black phosphorus. So student, black phosphorus, it contains two main allotropic forms. One is alpha black phosphorus and the other one is beta black phosphorus and their properties. Let us start with that. So take it on. Next one students, black phosphorus, the third allotropic form of a phosphorus, that is black phosphorus. So here black phosphorus, it exists in two different allotropic forms. Okay, this black phosphorus exists in two different allotropic forms, that is first one alpha black phosphorus and second one beta black phosphorus. Okay, first one alpha black phosphorus and beta black phosphorus. These are two again allotropic forms of black phosphorus. Okay, in that first one, alpha black phosphorus. Here student, alpha black phosphorus, it is obtained by heating red phosphorus. It is obtained by heating red phosphorus at 803 Kelvin temperature. In an inert atmospheric temperature, it gives alpha black phosphorus. So here, this is the preparation. Red phosphorus, which are heating in an inert atmosphere at 803 Kelvin temperature, it gives alpha black phosphorus. Alpha black phosphorus. So here students, here there are some properties about the alpha black phosphorus. First one, it is stable allotropic form of a phosphorus. And second one, it can be sublimed in air. Sublime means it can convert solid into gas. It can be sublimed in air and has opaque monoclinic and rhombohedral crystals. It containing two different opaque crystals. They are monoclinic and rhombohedral. And next one, it does not oxide in air. Okay, it do not oxide in air, means it do not react with the oxygen molecule. And it is a chemically inert. Okay, it is chemically inert. So these are the alpha black phosphorus properties. And here next one, beta black phosphorus. So here student, beta black phosphorus, first one, it is obtained by heating white phosphorus at a 473 Kelvin temperature. Beta black phosphorus, it is obtained by heating white phosphorus. Here white phosphorus which on heating at 473 Kelvin temperature in an inert atmosphere or in a sealed tube, it gives a beta black phosphorus. Beta black phosphorus. And the properties of beta black phosphorus are, it is the most stable and inactive allotropic form of phosphorus. It is most stable as well as inactive allotropic form of phosphorus. And next one, it does not burn up to 673 Kelvin temperature. And last one, When heated to 873 Kelvin temperature, it changes to red phosphorus. Means when a beta black phosphorus, if you heat about 873 Kelvin temperature, it directly converts into red phosphorus. So this is about the two important black phosphorus allotropic forms and their respective preparation and the properties. Take it. Next one, students, the important compound of phosphorus, that is phosphine. It is important for your annual examination. Phosphine. The formula for phosphine is pH3. Phosphine, pH3, important. Its preparation as well as the uses of phosphine. They are very important. So first one, phosphine. Phosphine, it is prepared by phosphine. It is prepared by heating. It is prepared by heating metal phosphides. Metal phosphides. By using metal phosphides, we can manufacture or we can prepare phosphide easily. So here metal phosphide we are going to take as a calcium phosphide, Ca3P2. Here we are taken as a metal phosphide. Phosphine is prepared by heating metal phosphide with water, nothing but H2 molecule, and HCl, hydrochloric acid. Okay, let us check the reaction. First one, calcium phosphide, Ca3P2. Calcium phosphide, it react with calcium phosphide. It react with water molecule. Calcium phosphide, it react with the water molecule. It gives phosphine, that is pH3. It gives phosphine. Just balance the chemical reaction. Ca3P2 plus 6H2O, it gives rise to 2pH3 phosphine, and remaining is 3CaOH twice. Slater line is obtained as a byproduct. This is the first preparation by using calcium phosphide and water. And second preparation by using calcium phosphide and a strong acid like HCl. Calcium Ca3P2, calcium phosphide plus 6HCl, it gives rise to 2pH3 phosphine, and the byproduct is 3CaCl2. 3CaCl2. Okay, calcium chloride is the byproduct. So these are the simple preparation of a phosphine. And next one, laboratory preparation of a phosphine. Laboratory preparation of phosphine. Laboratory preparation of phosphine by using phosphorus, that is white phosphorus with NaOH. Okay, here phosphine is manufactured or is prepared by reaction of white phosphorus with concentrated NaOH and water molecule. By using this concentrated NaOH and white phosphorus, we can easily prepare phosphine. Okay, so this is the reaction. Phosphorus P4, white phosphorus. This is phosphorus reacts with strong base, that is sodium hydroxide. With the help of water molecule, it gives phosphine, pH3. This is a phosphine, pH3, and 3NaH2PO2. 3NaH2PO2, sodium hypophosphite. sodium hypophosphite. So this is the laboratory preparation of phosphine, and these are the simple preparation of a phosphine. And next one, properties of phosphine. So here about the properties of phosphine means this phosphine is a colorless gas. It is colorless gas with a pleasant odor. And it is slightly soluble with water. It is slightly soluble with water. And it is highly poisonous in nature. I will write here the properties. It is highly poisonous in nature. When it contact with the strong oxidizing agent, it burns. Okay, when white phosphorus, if it comes to contact with the strong oxidizing agents, it burns. Okay, so these are about the preparation and the properties. And next one, chemical properties. Student, here chemical properties of phosphine. Chemical properties of phosphine. In that first one, phosphine, it is a first one, decomposition process. Decomposition of phosphine. Here, phosphine undergo decomposition. Phosphine undergoes a decomposition in the presence of photochemical reaction. It gives P4 molecule and 6H2. Means undergo decomposition, it produces hydrogen gas. And next one, this phosphine, it is a basic in nature. Actually, it is neutral towards the litmus paper. Okay, actually it is neutral towards the litmus paper, and however, it is also called a weak base than ammonia. Okay, and next one, uses. Phosphine, it is used in the Holmes signals and smoke screen. Okay, uses of phosphine. This is used in Holmes signals and smoke screens. So this is about preparation of phosphine and properties of phosphine, and there are simple properties like decomposition and basic nature and uses. Thank you.